In this tutorial video, we'll show you how you can make some basic use of the ArrayList Java collection library class. And if you want to look through the complete documentation for ArrayList, you can simply go to your web browser and use any search engine, for example, Google, and type Java API ArrayList. If you hit the search and simply just look for the latest version of your Java or whatever version that matches your computer. And for example, version number 8. If you go there, you can see the web page for ArrayList. You can see the documentation for what the class is supposed to serve, and also the list of constructors and also methods. So we're going to show you just the common ones in this tutorial video. But if you want other methods for your own application, you should always go back to this API page for the authoritative guidance. Okay, let's now go to Eclipse. Basically, I'm going to go through several basic usages of the ArrayList to give you a feel. And the way I'm going to do this is by, in parallel, I'm going to show you how to execute the ArrayList tester line by line. So this is a JUnit test that I'm going to show you. The various assertion to tell you how exactly the ArrayList is supposed to behave at runtime. So I'm going to execute line by line using the debugger feature for Eclipse. At the same time, I'm going to show you conceptually how you can think of how the ArrayList works at the runtime. So hopefully that will give you sufficient background in order to make other advanced usages of the ArrayList for your own application. Okay, so first of all, for ArrayList, the intuitive way for you to understand it is a resizable array, which means it's very convenient for you to insert or insert into the middle or to remove from the middle of the list without worrying about resizing the array. Okay, and one thing you should really note is the way we get access to the elements in the array list is pretty much like how you do for the one-dimensional array in Java. And indices simply start from 0. Okay, that's the only minor detail you have to pay attention to. Okay, let's just go to the code and then we're going to go through line by line. So what I will do is I will put a breakpoint in the first line of the test. So test ArrayList. So that's the test method we're going to go through for this tutorial video. So this line here, let me just launch the debugger over here. So I would say debug test ArrayList Java, or you can simply just go under whatever project you have for this particular JUnit test, and then you can say right click and then debug as JUnit test. That will also work. Okay, let's do it that way. So you hit it. Now I enter into the debugger perspective. Okay, later on, once you finish the debugging, you can either click on the stop here, or you can just go switch back to the Java perspective. Okay, either way. Okay, you got to do both. Stop and then switch back to the Java perspective. So now we are stopping at this line. Before we try to execute this line, let's try to under this line over here. So it is an assignment over here. And what we are doing is we're declaring a new variable called list. And then the type for the variable is of type ArrayList. And notice that with all the Java collection classes, each one of them is so-called generic class, which is covered somewhere else in your lecture notes. So the way, let's just talk about how you can use it. So first of all, after the ArrayList, you have to have a pair of angle brackets over here. You can see that's the left angle brackets, and this is the right angle brackets. And inside, you simply put a reference type for the type for each element in the array list. For example, string, or it can be a person class, or it can be a point class, or it can be a bank class, any class. Okay, so you simply just put a class name over there inside the angle brackets. So angle bracket is really the new syntax you have to learn in order to use the generic collection class in Java. And then we can simply say create a new and then array list. And then we simply repeat the declaration for the array list. And then this is the constructor which will simply create an empty array list to begin with. Okay, that's what we will do. Now, let's first of all to say step over in order to see how the list will be created. Okay, let's simply say step over here. As soon as we say that, you can see under the variables panel over here, if you don't see this variables panel, what you can do is you can go to window and show view, and then you can go to variables over here. If you don't see variables over here, you can simply click on other and you can look for the variables panel. Okay, so variables is one very useful feature. The other one that's very useful is so-called expressions. Okay, so we can just add expressions as we go to test the values for our object structure. And if you don't see expressions over here, again, you can go to Window and then Show View and go for expressions. Okay, so now let's go back to variables over here. So the list, if you simply click on that, you can see that over here in this panel here, it shows you the current contents. So the notation in Eclipse is to surround the contents of the list by square brackets. So currently you can see there's nothing inside the pair of square brackets, which means it's completely empty list. But notice that this array list does exist. So it is not null. It's just that the array list contains nothing. Okay, just empty. So that is why the first assertion we will do is to say assert true, and then we say the list is simply not null. Okay, and the next assertion we say is the list.size. So this is the first method you know. So .size is a method for array list. It tells you how many elements are currently have been added into the list. So we are saying expecting 0 to be returned. So it's empty but not null. Okay, so you will see that over here. If you just say step over and step over again, you can see these two assertions simply just pass. Okay, and now again, if you go to this list over here, how can I actually see the value for this list.size? What I can do is I can go to expressions over here, click on add new expression. I can say list.size. Okay, so what exactly what appears over there? If I hit enter, it tells me the value for list.size would be 0. Okay, you can definitely try between variables and expression to see whatever that's convenient for you. Okay, so let's say conceptually what we have got so far, this is how we can think conceptually. Okay, so we try to draw just some consistent view as the debugger, because you don't necessarily got access to the debugger always, so you should really have a good picture in your mind how the array list will work. So what I would do is, let's just draw that. So we create a variable called list. Over here, it is simply pointing to somewhere. I would say, since it is empty to begin with, but it does exist, I'll just say something like this, just for empty. Okay, you can have different notation for empty for your own purpose. We're just saying nothing is there so far. So if I say list dot size, at the moment, as we saw from the debugger, at the moment it's simply just going to be 0. Okay, that's what we have achieved so far. And now, if we try the next assertion over there, what the method we are trying to call is called contains. So we are simply asking, because every element in the list is a string. How do I know that? If you go back to the line where it is declared, we can say every element in the array list is simply a string. So we say list that contains A. Because the list is simply just empty at the moment, or you can see from the debugger, the list, if I see under variables, the list contains nothing over here. So that means if I say list that contains A, that would simply be false. And then I simply put the negation here, so not false would be true. So assert true will just pass. Okay, hopefully you see the logic over here. And then if we go to the next one, so we want to figure out, so there's another method here we're calling, which is index of. So given any string value, we want to know if the element exists in the current list. We want to know where it is in the list. It can be from indices of 0 until size -1. Pretty much like for the primitive array, it will be from 0 until array.length -1. The same idea. But if the element we are passing here does not exist, then we simply just return -1. So because currently the list is simply just empty. So if we try to say index of A, it's simply going to give us -1. Okay, you can also try this before we try the assertion. What you can do is you can say list dot index of, and then put A. You gotta make sure you type it correctly, otherwise it wouldn't execute correctly for you. If I say that, it's going to be -1. Okay, you can see expecting -1, and then it's indeed returning -1. So if we step over this one, that assertion on line number 16 also passed. Okay, so far so good. So far we just got an empty list where if we simply say list dot index of A, it will return -1. If I say list dot index of B, it will also return -1. Okay, the same idea. So now let's try to add something to the end of the list. So you have at least there are two common kinds of add method you can call on the list, on the array list. One is simply add. So add simply means I'm going to append to the end of the current list. Because the current list is simply just empty, so what I'm trying to do is, let's predict what's going to happen conceptually. I'm trying to predict to the end of the empty list A. So that means something like this. Let me just use a different color here. So that means I'm trying to dynamically resize the array, and then I'm appending A to the end. Okay, that's what I'm trying to do over here. Okay, so when I say list dot add, and then A over here, this is the consequence. Okay, so simply append to the end. And the next line over there, so now let's see also from the debugger. As soon as I say step over, it's going to execute line number 19. As soon as I say that, if I go back to variables and then click on list over here, you can see now we do have an element over here, A, just a single element, right? So now if you say list.size, go back to expressions here, you can see list.size, the expression we entered before used to be 0 because the list was empty. But now after adding A, list.size will become 1. And also if we say list.index of A, in this case, because A will be the only element in the list at position 0, indices start with 0. That's why these two expression values actually have changed accordingly. Okay, don't be too surprised by that. And also for variables, it also shows you the contents of the list, which is also very useful. Okay, so now after this line 20, we can easily predict what's going to happen, right? If you try to add just another element to the end of this list, let's try to predict what's going to happen. Let me use a different color here. So now, for example, I try to append B to the end. So that means I'm simply just do append B at the end. So when I say list dot add B to the end, so this is the consequence. And by the way, you can see the indices indices wise, this is index 1, and over here this is index 0. Okay, 0 and 1 indices, like an array. Okay, so now these assertions should really make sense to you. Okay, to really save some time, let's just go over that quickly. So now when you say list that contains A, that should be true, because A indeed exists over there in the list. And also when I say list.index of A, of course it's at index 0. Okay, and then when we say list that contains B, of course because it's at index 1. And let's now try this one here. When I say list that contains element C, right, we can also try that. If you simply go to over here, list dot contains C, it's just going to evaluate this expression here at this moment. At this moment, it will simply be false because C simply doesn't exist in the list. But later on, if we added C to the end of the list, was somewhere in the list, this expression value will become true, right? Just to notice the difference here. Okay, so now this will simply be false. That's why you see we added an exclamation mark for logical negation to say not false will be true. And then the index of C will just be -1 because C does not exist. If you just want to verify, you can also do that. List dot index of C over here, that'll be -1. Okay, so now let's see another kind of add method. Okay, so this is something called overloading. You can see add over here has the same name as the add over here. However, their expected input argument types are different, right? It's called overloading in Java. So over here, you can see here we are expecting only one single element, and it's simply an element A, right? Element like A, just one element value. But over here, we also have an extra argument over here, which is where would you like to insert or to add this particular elements. Okay, let's see how we can do it. And now over here, when we say list.add at index 1, I want to insert C. Okay, let's see exactly how this is going to work on the iPad, and then we'll see from the debugger to verify that. Okay, so now let me first of all write it down exactly what we are going to execute, and then we'll see how that's going to work out. So we have list dot add at index 1, and then we want to insert element C. Okay, so what does that mean? That simply means we're going to insert C over here, and then such that C will go between A and B. And after that, C will have index 1, and then B will have index 2. Shift everything that used to be at index 1 to the right by 1 position, basically. Okay, so now how can we do it? So what we can do is, let me try to see if this might work. Okay, what I will do is I'll try to just move this part over here dynamically. Okay, let me just do it again. What I will do is I'll put this, so that means we move this guy over here, and then dynamically we're also going to insert C at index 1, right, over here. And of course we have to change the index for B accordingly, which will be index 2. Okay, hopefully you see that's why I say it's a resizable array over here, right? So dynamically all the resizing and shifting the element to the right by 1 position, all the tasks are done for you, because this is a library class that's already implemented. So after this particular line, what we have is at index 1, we simply got C over here. Okay, so hopefully you can see how things work this way. Okay, so now if we go back here, and also we say list.add the next one. Before we see that line, why don't we simply just try to get to here? Okay, let me just speed up a little bit. So what I can do is I can just make sure I can go all the way to here at line number 31, and then I'll simply just go another one's step return. Okay, so I'm here. So that means all the assertions before that have already passed. So I was not stopped by any assertion failures. So now we are here at line number 31. So what I would do is I will try to execute this line and make sure the new list is exactly like this, like A, C, and B. Okay, let's make sure that's really the case. So what I would do is I would say step over, and if I go back here, variables, and then click on list, I got A, C, and B, right? Exactly like that. So now can you predict what's going to happen over here? So now we say list.add, I want to add to position 0 element D. Okay, think about what's going to happen, but at the same time I'm going to just draw that on the iPad over here. I'll use pink over here. Let's say list.add, and then I want to drag add to position 0 and then the element D. Okay, this one over here, what I can do is I can first of all move the existing list conceptually a little bit to the, let me do it again. I can just move the whole thing a little bit to the right over here, and then I'm simply going to expand it like this way here. And then it's going to be index 0, and then it's going to be D. Of course, all the affected indices have to be changed accordingly. Of course, this is done by Java. You don't have to worry, but let me do it. Okay, so that means this element here is going to be index 1, and this one over here is going to be index 2, and this one here is going to be index 3. So 0, 1, 2, 3. So that means after that we should get D, A, C, B. Okay, so now let's verify that's the case. Let's go step over. You do have D, A, C, B over here. Okay, so now these should not really be seem strange to you. So we simply say list that contains D, and let's just do one for example. You can do the rest by yourself. List that contains D. Indeed, D is at index 0. So you can see this line here is going to, line number 34 is going to return true, because list that contains D will just be true, and also list that index of D, of course, is going to be index 0. So that means the expected value 0 will be satisfied. Okay, so let's just go over these assertions here. I'll leave them to you to actually go over to make sure you understand. Okay, now let's go through one more method that you can also use. So we talk about two kinds of additions, either to add directly to the end of the list. One more thing to show you, hopefully you can also make this kind of observation already in your mind. So we talk about these two add method. Let me just talk about them over here. So you can say add, and then I want to add an element E. Okay, versus if I say add, and over here I can pass some index value, and then I can just do another element over here, right? So now under what circumstances will these two method executions be equivalent? Okay, so basically we know that implicitly this add is going to add to the end of the list, right? And over here, the add here, where exactly it is going to be added depends on what we specify over here. So if this value here happens to be the ending index for the list, then that will work. So what I will do is I will simply put some value over here for you to try as well by yourself. So over here, I can simply say list dot size. Okay, for example, let's say if I want to add another value, let's say called E. If I simply say add E, I know that E is actually going to become over here, for example, over here, which will be 4 over here, right? So in order to know what this value 4 comes from, it is simply the size before I add the is simply the size of the list before this addition occur, which means I got 1, 2, 3, and 4 elements there. So if I say insert into index 4 E, so that will actually work as if I simply say add and then E, right? So that's why this is the value that you can actually see this happens to be equivalent to this method here. Okay, so these two hopefully they will strengthen your understanding. Then you go back here, and then what about remove over here? So remove here simply just going to remove whatever element you're passing. If the element exists, it's going to remove it. If it doesn't exist, it's just going to ignore. Now in this case, we know that element C does exist. How do I know? For example, you can go back to expressions over here. You can say list dot contains C. Oh, actually I got it already, but anyway, I'll just type it once more. Okay, simply true. That means we can remove it. So now, how does that work conceptually? If I want to remove, for example, C. Okay, let me just remove. Sorry, it's too big. What I will do is, let me just erase this part here. Okay, that was only for illustration for the previous of the observation I made. So what I will do is, let's think about what's going to happen if I say remove C. What I will do is, so if I say list dot remove C over here. So what's going to happen is, conceptually, I'm simply just going to remove C over here, and then whatever that used to occur to the right of the element where I just removed, I'm going to shift them to the left and then combine with the rest of the list. Okay, so that means we also have to change the indices accordingly. In this case, this will become just 2. So we got 0, 1, and 2. So we only got D, A, and B. Okay, hopefully that makes sense to you. So what I would do is, as soon as I say step over, so what I will get is, I'll go back to variables over here. I got D, A, and B. Okay, so 3 elements. So now you can just work out these assertions should just pass, okay, without any failure. I'll just go over them. Okay, I'll put a breakpoint over here, and then I will say return. Okay, so now I go directly to this line here, and the execution is still pausing. Now, finally, I want to show you 2 ways for you to iterate through an array list. One way to do it is do it as if the array list is simply like a one-dimensional primitive array. So this loop should really look familiar to you. I can have a loop counter I, and then starting with index 0, and I is less than list.size. In the case of one-dimensional array, you would say array a dot length, right? That's what you would say, and then I++. And then let's say we simply want to concatenate all the string elements one after the other. So we can say concat 1 plus equal, and then we have another method here to show you, which is get. Get is pretty much like a square brackets notation in the array. Okay, just go indexing into the array list. So we can say get the elements in the array list at position I. Okay, so this is basically like what we are used to for the primitive array notation. Okay, so this one shouldn't be too surprising to you. And after this, we should go exactly DAB. Okay, because now we do have only DAB in the array list. Okay, let me again to really bypass the loop. Okay, actually we can just look at one particular iteration just to show you how you can do the debugger for the loop. What I would do is I would say step over, okay, and then the current value. So this is how you can do it. Okay, the current value for I. Okay, so because we are simply at the beginning of the loop, we haven't even initialized the loop just yet. Okay, so now I doesn't exist just yet. Okay, what I would do is if I say step over, now I has been initialized to 0. Okay, and then you can see I. Okay, and then I can say list.size over here is simply just 3, and then I say I less than list.size, which is true. That means I go into the loop for the very first time. And now for the very first time, I'm gonna have list.getI. I can just copy this notation here, and then I'll paste. List.getI will just be D. So that's the very first element I'm gonna get eventually. Okay, now if I say step over again, so now I'm going to the second iteration. So now I is going to be, not yet, but it's going to be incremented I++. So if I say step over again, so now I has been incremented to 1, and then the size of the list remains the same, and the state condition is still true. That means I stay here for the second iteration. And now list.get 1 will give me the second element, which is A. Okay, pretty much like going over through D followed by A followed by B. Okay, so hopefully you can see the pattern over here. That's exactly how you can go through the array list for your own application and then sometimes debug when necessary. Okay, let's now go to the beginning for the second loop I would like to show you, which is some new syntax for you possibly, so you can learn. So now, the second syntax is so-called for each loop, which means you can do the iteration over the array list without using an explicit loop counter like I. We don't have to. As you can see, for this particular for each loop, we don't use any I counter, right? Like a loop counter over here. So now let me explain this over here for you. This is how you should understand the syntax over here. Let me switch the iPad and let's see. Let's review what we have got so far, okay? The way we declare, so let me just put it here. Let me draw a bit better. Okay, let me just put over here some notes here for you. Remember how the way we declare the array list was like this. We say array list, and then angle brackets string, and then we put list over here, and then initialize to whatever over here, the new expression there. And now when we say for each loop, just say for, okay, and then we simply, let's see this is how we write it, but I'll explain in just a moment. And then this s is just some new variable we introduce, and then we have colon over here, and then we simply put a list over here. Okay, and then over here inside the body of the loop, we can simply just do some usage of s. Okay, let's try to understand how the syntax is supposed to be understood. First of all, let's see over here. We have every element in the array list being a string. Okay, and then what we say over here for the for syntax over here, what we're saying is we're going to have a new variable called s, such that s is going to be assigned in each iteration of the loop an element from the list. But what's the type for each element in the list? We know pretty well. It's simply going to be of type string. That is why we declare string type over here. Okay, so you can think about this is also like a dummy variable over here. So this is going to be reassigned to an elements in the list for each iteration. Okay, and now maybe for the very first iteration, s is going to be reassigned to D over here, and for the second iteration is going to be reassigned to A, and for the last iteration is going to be reassigned to B. However, this kind of reassignment is actually done automatically for you at the runtime. So that's why the for each loop is in some ways more convenient than using an explicit loop counter, right? Okay, now So now whenever you use S for the very first iteration, S will just be D, and then second iteration will be A, and last iteration will be B. And one more thing to really note. So the way you declare this has to be very careful. First of all, you put the array list after the colon over here, to the right of the colon. So now for those of you who actually understand a little bit math, so this colon here simply means the membership operator, which means S is declared to be a member of the list. A list is simply a collection of elements, like a string value, and S is simply just a member of them. And for each iteration, we're going to reassign S to one of the members in the list. And what should be the type of the list? The way we determine the type for S is simply by looking at the declaration of the list over here. And because each element will be a string, so over here we should put a string. If you put something like an integer or maybe double or person, it's not going to compile. Okay. Hopefully you see the syntax over here. Okay, now let's just see that over here. What I will do is, let's see if the debugger can confirm with us. So now if I say step over, let's go to the very first iteration over here. What I would do is, first of all, it's before we try to execute this line here. So if I just put S over here, oh, actually it's already the first iteration. So now what we will see is, in the very first iteration, S will be reassigned to the very first element, which is D, okay, at index 0. Pretty much like the very first iteration for list.get I, right? So now, if I say step over again, if I go to the second iteration, you can see S has been reassigned to the second element, which is A. Okay, and shouldn't be too surprising to you. If I go to the third and last iteration over here, you can see it should be B, right? Let's confirm that in the debugger, and it's indeed B over here. You can see this for each loop and this for loop over here, they're completely equivalent. And the convenient points about using a for each loop is you do not have to worry about the indexing or using an explicit loop counter. You can simply just say, as long as you can declare correctly the type of the elements and then give a new variable name, for example, S, you can make use of it as if you said get I, list.get I, that you had to do in the case of the conventional loop over here. Okay, so these two kinds of loop, you can choose whichever you prefer. They both work. Okay, so now after this, we'll just go over and then exit from the loop and then assert equal, that should be D and B. Okay, after that, so we simply just pass all the assertions. Okay, let me just say stop over here. Let me go back to Java, and then of course, if you simply run the whole JUnit test without debugging, you can see everything just passed. Okay, hopefully you can see the way some basic features work for the array list. Again, if you want to see other methods, go to the API page on the web, and also always remember the way it works for the indices starting from 0, like how we illustrated in this tutorial video.